So a quick explore first, team. We have got the new function is a little bit like the hyperbola function, which is why I knew we could get it done this lesson as well. So the base function is there, f1 of x. It's f1 of x, or y, is equal to 1 on x squared. And what I want you to do, first of all, you might want to have a think about it first, is I want you to think about what that shape would look like compared to, say, the hyperbola function. How is it going to be different? I'll give you a couple of starter questions to think about, and then you can either think about it yourself or chat to the person next to you for about 30 seconds or so. How is it going to be different? Don't just do it in Desmos and find out for yourself. I want you to be engaging and thinking about your math rather than just cheat sheeting to the end. Okay, and that also includes not asking Alex as well. Okay, so have a think about it. The two guiding questions I got for you is think about the asymptotes to start with. You know, putting it as 1 over x squared, how will that affect the asymptotes? Again, the way we looked at asymptotes last time was we thought about or wrote down stuff about the extrema, about what's happening when x is getting to infinity and negative infinity, when x is equal to 0, when x is positive, when x is negative. Thinking about the values of that, substituting numbers in and stuff just in your head even, will give you an understanding of what's happening to the function. And how will it affect the shape is the other question that I'm going to ask you as well, or get you to think about. So I'm going to pause the video and so you can have a... Okay, halfway through me explaining stuff, I've started the video up. So the vertical translation happens the same way as well. If I look at k, if k is a positive value, the whole graph goes up. I've done something there. What have I done? Disappeared. I'll figure that out later. You can see the vertical asymptote goes up and the graph would be up here as well. For some reason it's not showing, but that's okay. I'll figure that out later. And if I go k is negative, then the graph goes down. That's probably a bit better. Goes down like that, so there's the graph there. So if k is negative, you're going to have an x-intercept, probably 2, almost definitely 2. If h has a value along here or along here, we're going to have, along here, when h is over here, we're going to have a y-intercept of some description. So sometimes you have to work it out, sometimes you don't. And yeah, that's basically it. You can obviously just have like a is equal to 2 or maybe negative 2. So this would be reflected with a dilation of 2 in the direction of the y-axis, with a translation of 1 unit to the right and the translation of 1 unit down is the new graph. I'll get rid of the other one so you can sort of see it a bit more clearly. So that would be the transformation. So again, the process is exactly the same as it is for 1 on x. It's just being aware of the shape, which looks like a tree trunk, either the right way up or upside down, depending on whether it's reflected. And as always, you're just looking for the x and y intercepts. Okay, I'm going to go through a couple of worked examples. Just for the video, I'll just really quickly say, just for the video, just for the giggles, I'll put these back here. And just for the video, I'll say there is the parent graph again. Looks like a tree trunk. What was down here has been reflected up here because when we square a negative value, we get a positive number. So all of those y negative values become y positive values, and that's why it's symmetrical and a bit like the parabola and stuff like that. Okay, any questions before I move to a worked example? Okay, I'll be as quick as I can. Here we go. Here's some theory notes for you to write down. Base function is y equals 1 on x squared. The domain of the base function is x is a member of the real set, except 0. 0 is not in there. For the range, y is a member of the real set. How do I finish that off? I'll go back to the graph. I'm going to flick over to the graph now. I'm sorry if that's a bit confusing for people writing notes down, but it's for a good reason. I haven't written it down yet. What's the range? The hyperbola range was y is a member of the member of the real set without 0. It's not the same for the truncus. Snake, I feel like you've got an idea there. Yeah, you're 100% true. That is 100% true above K. But for the base graph, it's everything above 0. Good. The way we write that in a bit more formal language is we simply write y as a member of the real set positive. In other words, y has to be a positive real number. It can be 0.00001 times 10 to the negative 99. That's fine. It can be as tiny as you want, but it can't be 0. But anything else is fair game. So the range is y as a member of the real positive set. And so if you are doing a value above, like if K changes, we're going to have to change our notation a little bit when we have transformations involved. Okay. Give you a moment to finish that off. Okay, just moving on. I'm probably moving a bit fast for some people's writing skills, but this will be on Google Classroom before the end of the day. Just trying to remind you of the language here. Here's the truncus again. So we've talked about the domain, we've talked about the range. I'm not going to write this down, but is the truncus an example of a one-to-one function, or is it one-to-many? Who reckons one-to-one? Raise your hand in the air. Who reckons one-to-many? Who's still struggling with low-risk activities like putting your hand up for something that doesn't matter? You are? It's... Oh, have I got it the wrong way? It's not one-to-one. We'll put it like that. It's not one-to-one. Because if I take the value 2, I get the value... Oh, that's probably done one. If I take the value 1, I'll go up to 1 here. Yeah? But if I go to the value -1, then I get to 1 as well. So multiple values of the domain map to the same number in the range. It's still a function, but it's many to one. It's not one-to-one. Yeah, I got that wrong round in my head the wrong way. Okay, so it's like a parabola. It's like a quadratic. That's many to one as well. It's not one-to-one. So a hyperbola was one-to-one, but this is many to one. So if you said one-to-many, I hope that makes sense why it's not. Okay, so worked example really quickly. The question in the textbook is here, and it simply says, state the transformations required to change the graph 1 on x squared to -1 over x minus 2 all squared minus 1. Okay, so we're going to list them in order from DRT. So, is there a dilation? If so, what is it? The answer is no, and it doesn't have one. Good. Okay, so there's no dilation. It does have a reflection. Just because the minus is on top here, it doesn't matter. That minus can be popped outside the entire function. It's minus 1 on x minus 2 all squared. So number 1, it's reflected about the x-axis. Okay, that's the reflection, DRT. And then we just need to list the 2 translations. It doesn't matter which order you do them. So I'm going to say translated to the right, 2 units. And number 3, translated down by 1 unit. Done. give you a chance to catch up on that, and then I just want to say one little more thing about it. Okay, the question doesn't ask this, and I'm just going to do it in blue on this slide and squish it in. But if it asks you to sketch it, you should be able to translate that. And you might see that this has a y-intercept. So if I go for a y-intercept, we do it the same way as we normally do. Y-intercept, let x equals 0. So that would be y equals minus 1 over minus 2 squared minus 1, which would be minus 1 quarter over, minus 1. And so that would be, I don't know, let's just go minus 1 and a quarter. That'd be the y-intercept, 0, minus 1.25. Is that okay? Okay, squishing it underneath this now. The x-intercept, just to remind you, we do it the same way. We let y equal to 0, and we solve. This is fine. We've got a minus 1, so it's not going to be a drama. 0 is equal to negative 1 over x minus 2 all squared minus 1. Now, I'm going to add 1 to both sides. So that'll give me 1 is equal to minus 1 over x minus 2 all squared. Is that okay? Add 1 to both sides. Now, that x minus 2 all squared needs to be elevated in order to get at the x. So we're going to multiply both sides by x minus 2 all squared. And so we're going to have x minus 2 all squared is equal to minus 1. Yeah? And that gives us x minus 2 is equal to the plus or minus square root of negative 1. Uh-oh. When you get to that point, you can add an extra axis and start graphing complex numbers and you're good to go. But in terms of the real set of numbers, square root of negative 1 does not exist, right? So this tells you that there are no x-intercepts. That could be for one of two reasons. Number one, because the truncus is fully underneath the x-axis, or number two, you made a mistake in your working out. I can tell you now there is no mistake in the working out. So it's because, again, I don't think I'll draw it because I want to sort of race on. Here, we've done a reflection, right? So now the truncus is upside down. The tree's facing downways. Here, I've then made the horizontal asymptote minus 1. So it's underneath the x-axis. So the whole trunk, is underneath the x-axis. Therefore, there are no x-intercepts. So it all works. It all makes sense. I just wanted to show that if you did do the algebra calculations, that confirms what you should know anyway. Is that okay? Just a little aside, really. The other two worked examples, I'm only just going to do verbally by looking at the screen, looking at the textbook. So worked example 12 just says, for the function y equals 2 on x plus 2 all squared minus 4, state this. Now, I kind of feel like they overblow it really in the textbook. Like they make you write the general formula for the truncus first with all the possible transformations. And then they sort of do this kind of stuff, and then they kind of do it again. I'd kind of just be more likely just to really just use your understanding of transformations in a bit more broad sense. So 3 plus x here is the same as x plus 3. So that makes, if we know that means that it's been translated to the left by 3 units. Yeah, to the left. So that would be a minus 3 for the vertical asymptote. So I would go straight down to an asymptote of x equals minus 3. We've got a minus 4 here, so that means we've got a horizontal asymptote of y equals minus 4, and we can read that straight from the function. So I wouldn't necessarily bother with this. You can do it if you really want the formal writing down of stuff to help structure your brain. That's fine, but you can just look at it and observe and go, yeah, I've got it from there. You can see the domain of the truncus is R without the minus 3. And you can see the range here, we have to use a different language. I would probably not use what it says there, y is greater than minus 4. There's a few ways we can write it, but probably the most formal way I would bother writing it is like this. I'm just going to do it on AirSketch so you can see it. So we can see that it's gone down by 4 units. So the truncus, I'm not going to draw it properly, but the truncus is going to be something like Was it left, wasn't it? It's going to be something like that, yeah? Oops. Yeah, like that. Okay, so we've got the domain is fine. That's just all real numbers, but it can't be -2. That's fine. But for the range, that's a bit trickier. It would be all real numbers is how I would put it. But then I'd put a comma and then say y is greater than -4. That's how I would do it. There are more technical ways of writing it, which is better, but I don't want to introduce you to that now, and I don't think you actually ever need to be introduced. If you want to see a more formal way of writing that set, let me know and I'll show you. But otherwise, that would be okay. You're saying y is all real numbers, except y has to be greater than -4. That's the extra condition. So it kind of operates like that, but for a bigger range of numbers, I suppose. Does that make sense? Interval notation would be fine as well for those who are used to it. So if I'd gone y is a member of -4 to infinity, that would be beautiful as well. That describes it very well as well. That's it. I'll stop the video.